figure out the height of the tree to get the ball down.
All right, well, who knows the answer to their question? How can they find the height of the tree? Hopefully you remember from geometry, we can use right triangle trig to find the height of the tree. And trigonometry is the title of our next unit, so be excited. Most of what we do today will be review, and then we'll just keep adding on from there. Okay, so today our goal is to understand and use right triangle trig to find ratios and missing angle measurements or missing measurements. Okay, so first little review, what is trigonometry? Sorry, I'm still trying to find the best place for my head. We'll try it down here today. We'll make it a little bit smaller. All right, so trigonometry is a branch of mathematics that studies triangles and then the relationships between the lengths of their sides and their angle measurements. Who uses trigonometry? So we will do a lot of basic problems where we're just finding missing heights, missing angles, but surveyors actually use this a lot. So this is definitely a branch of mathematics that has applications in lots of different fields, just beyond like, oh, you'll use it in calculus. Okay, so first of all, what are our trig functions? We have sine, cosine, and tangent. Sine is the angle, the sine of the angle theta is the ratio of the length of the opposite leg of the length of the hypotenuse. So sine is opposite over hypotenuse. And again, the sine of the angle is a ratio. Okay, what we are putting into the function is an angle. What we are getting out of the function is a ratio. Cosine is a ratio of the adjacent side and the hypotenuse. So notice here we have this theta. That's denoting our angle that we're looking at. And all of these words of adjacent and opposite are based off of that angle. So opposite is the one that's all the way across from it, in this case the 4. Adjacent means next to, it's the 3. And the hypotenuse is always your longest side. It's across from the right angle. All right, last one we have is tangent. Tangent is the ratio of the opposite side to the adjacent side. Now, something that's probably new for you is the reciprocal trig functions, okay? Sine, cosine, and tangent all have a reciprocal function, and those are called cosecant, secant, and cotangent, okay? And they are literally just the reciprocal of what we had before. So before, what we saw was sine of theta is opposite over hypotenuse. Notice right here, the cosecant is just the reciprocal of that. It's the hypotenuse over the opposite. So once you find sine, cosine, tangent, it's real easy. Just flip those fractions, you'll have the reciprocals. The names of these are cosecant, that's the reciprocal of sine. Then we have secant, is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And personally, I think it's pretty easy to remember that tangent and cotangent go together. What's harder for me is remembering that sine and cosecant and cosine and secant go together. The way that I remember that is I remember that you have an S and a C in each pairing. So sine goes with cosecant, so we have an S word and a C word, and then cosine goes with secant, so you have a C word and an S word. So it's just a little trick that works for me. Hopefully that'll help you out a little bit. Okay, so let's do some examples and practice finding these ratios, okay? First one we'll do is number 1. Okay, let me switch colors. I don't really like writing in red that much. I haven't used green yet, but this pen size seems kind of large. Okay, so first one, we have to first pay attention to where is our angle. Our angle theta is in that bottom right corner, And we're going to find the sine of theta, which is opposite over hypotenuse. And let's label those sides. So hypotenuse is always the longest side across from the right angle. Opposite is always opposite the other side of the triangle, okay, from the angle, which means adjacent is next to the angle. All right, let's write our fractions and we'll reduce them as well. It is an expectation in this unit that you reduce your fractions correctly. Okay, so opposite over hypotenuse, that would be 9 over 15. Reduce that to 3/5. All right, next one, cosine, adjacent over hypotenuse. So 12 over 15. And that will equal then, divide them both by 3, 4/5. Last one, tangent. The tangent of the angle is opposite over adjacent, 9 over 12. Reduce that fraction. We have 3 over 4. And those are your 3 ratios, and that's it. I'm going to leave the next 2 for you to do on your own, and we'll check our answers in just a moment. But before we break for that, let's do one more together, but this time we're going to do this number 4 here, where we have to find all 6 of the trig functions, okay? So we'll start by doing one more time sine, cosine, tangent, and then we'll find the reciprocals. So first I'm going to notice where my angle is. My theta is right here in the bottom left, and I'm going to label, just like before, opposite, adjacent, and hypotenuse. Hypotenuse is always the longest side across from the right angle. Adjacent is always next to my angle, and opposite is all the way across. All right, sine. And sometimes what's helpful for me too is to write my SOHCAHTOA on my paper so that I remember that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So we call that SOHCAHTOA. Is usually what we say to remember that. All right, so sine opposite over hypotenuse is 15 over 17. There is no common factor, so I don't get to reduce. Cosine adjacent over hypotenuse, 8 over 17. Again, it's already simplified. Tangent of theta, opposite over adjacent, 15 over 8. Again, no way to reduce. All right, so now we're going to write the reciprocals. We can just take this fraction, 15 over 7, and flip it. 17 over 15. Next one, 17 over 8. Just writing the reciprocal of my fractions, 8 over 15. Okay. I want you to, before you go on to the next video, take some time, finish examples number 2 and 3, and then number 5, and we'll check our answers in the next video and do some word problems because those are fun.